Machine learning. You've probably heard that term 1,000 times, right? But what does it really mean when we say a computer learns? It's not just about memorizing stuff. Today, we're going to break down exactly how it works. And trust me, it's probably a lot simpler than you think.
So let's get right to it. How do machines actually learn? It's not like you or me cramming for an exam the night before. No, it's a very specific process. And the core idea behind the whole thing? It's actually pretty straightforward.
And believe it or not, it all boils down to just one number: 3. Yep, there are really only 3 fundamental ways a machine learns from data. And once you get these 3 down, you'll basically have the keys to understanding the foundation of almost all modern AI. All right, so here's our game plan. We're going to dive into what are called supervised, unsupervised, and reinforcement learning. Then we'll pull back and see how they all fit together in the big picture. So let's get started. First up, let's talk about the most common type you'll run into: supervised learning. And honestly, the clue is right there in the name. Think of it like there's a supervisor or a teacher guiding the whole learning process. The best way to get your head around this is to just imagine you're back in school, sitting in a classroom. The teacher hands you a math problem, but here's the key. They also give you the correct answer and show you exactly how they got it. Now imagine doing that not once, but thousands, even millions of times. Eventually, your brain starts to see the pattern, right? And pretty soon, you can solve brand new problems all by yourself. Well, that's exactly what supervised learning is. In more technical terms, the machine gets fed a massive amount of what we call labeled data. Think of it as data that comes with a giant pre-made answer key. The whole goal is for the machine to figure out the relationship between the questions and the answers, so that eventually it can make really accurate predictions on new data it's never ever seen before. And here's the cool part. You use this stuff every single day, probably without even thinking about it. You know your email's spam filter? That thing was trained on millions of emails that real humans had already marked as spam or not spam. Or think about websites that predict house prices. How do they do it? They've learned from tons of data on past home sales. The main takeaway here is super simple. If you have a bunch of data that already has the right answers, supervised learning is your go-to tool. Okay, but what happens when you don't have that nice, neat answer key? What if you're just handed a giant, messy pile of information with no labels, no instructions, nothing? Well, that brings us perfectly to our second type, unsupervised learning. So for this one, I want you to picture something. Imagine you walk into a room and it's a total mess. There are tools, clothes, and books just scattered everywhere. No one tells you what goes where. What would you do? You'd probably just start sorting, right? You'd naturally make a pile for the tools, a pile for the books, and another for the clothes. You find the hidden structure all on your own. And that right there is the whole idea behind unsupervised learning. The machine just sifts through all this unlabeled data and looks for hidden patterns or natural groupings, we often call them clusters, all by itself. It's not trying to predict a correct answer, because there isn't one. It's all about discovering the underlying structure of the data. It's really pure exploration. Just think about how powerful this is in the real world. You know how online stores recommend products? They use this to group customers with similar shopping habits. Or what about on your phone? How it magically groups all the photos of the same person together even if you never tag them. That's it in action. It's all about the machine finding these hidden connections in the data that a person might just not see on their own. Okay, on to our third and final type. And this one, reinforcement learning, is a whole different ballgame. It's not about learning from a static pile of data, labeled or not. This is all about learning by doing, through pure trial and error, usually in a live, dynamic environment. The absolute best way to think about this is training a dog, right? When the dog does something you want, like sitting on command, you give it a treat. That's a positive reward. If it does the wrong thing, well, it gets nothing. And over time, through that simple feedback loop of rewards, the dog figures out which actions lead to the best results. You know, more treats. That simple feedback loop is the core of reinforcement learning. We have what's called an agent. That could be a piece of software or a physical robot, and it takes an action out in its world. It then gets feedback, either a reward for a good move or a penalty for a bad one. And its one and only goal is to figure out a strategy that gets it the most possible rewards over time. It literally learns from its own successes and failures. This is the magic behind those mind-blowing AI systems that can beat the world's best players at super complex games like chess or Go. No one gave them an answer key on how to play. They just learned by playing millions and millions of games and getting a tiny reward every time they won. It's also how we teach robots to walk and keep their balance, by letting them try, fall over, and adjust over and over until they get it right. Okay, so there you have it. Those are the three big ways that machines learn. We've got the teacher, the explorer, and the student of trial and error. Now, let's zoom out and put them all together to see how they really stack up against each other. When you boil it all down, it's actually pretty simple. Supervised learning needs labeled data. It needs that answer key. Unsupervised learning works with unlabeled data to find patterns all on its own. And then there's reinforcement learning, which doesn't even start with a data set. It learns as it goes from a live stream of rewards and penalties. So you might be thinking, okay, why do we even need three different types? Why not just pick one and use it for everything? Well, it's because different problems need different tools, right? You wouldn't try to drive a screw with a hammer. It just wouldn't work very well. Choosing which one to use is actually pretty intuitive. It goes like this. Got a bunch of data with the answers already there? You're going to use supervised learning. Need to just explore a big chunk of data and see what's inside? That's a job for unsupervised. And if you need a system to learn the best way to act in a live environment to get some kind of reward, that's reinforcement learning, hands down. It's all about matching the right tool to the right job. But amidst all this amazing technology, it's really important to remember one key thing. Machine learning is here to support humans, not to replace them. At the end of the day, we're still the ones in charge. We choose the data, we set the goals, and we decide what to do with the results. Think of it as a powerful tool that just makes our own intelligence even better. So, as you go about the rest of your day, I want you to think about this. From your email spam filter to your phone's photo albums to the shows that get recommended to you online, which one of these three types of learning do you think is having the biggest impact on your life right now? It's something to think about. Thanks for joining me for this explainer.